I believe so. So let's go on with this next presentation. Next presentation was by Wieslaw Popielarski, who is a Scala IDE contributor right now. He works at Virtus Lab, and we'll be talking about few useful tools. Actually, two useful tools.
Exactly two. Yes, exactly.
Exactly. Okay, go.
Okay, so I'm going today to talk about two tools in our toolbox in Scala IDE. I choose these two because I think that they are most interesting, and I think that they could encourage you also to join contributors and make pull requests to our open code. So we are not limiting to ourselves. Julian today said that there are 3 or 4 people contributing to Scala IDE. We are waiting for new soldiers. Yes, so we are looking for new recruits. So about me, actually I'm involved in Scala last 4 years, and I'm showing it just to say you that you are not too old to start new things. Okay. These two tools are expression evaluator. This is quite new thing, but maybe it's not the newest one. Yes, it's a new, but rarely used because unfortunately it was working only with Scala application, because Scala application required a launcher which also make available Scala VM debugger. So its own implementation. Now we added also launcher for JUnit, Scala test, also for remote debugging, and also we support some PDE launching. So right now, expression evaluator can be used almost everywhere you need. What for it is, I will explain it later in example. The second thing is async debugger. I choose this one because there is a solution which maybe is quite similar to that what was done by people from IntelliJ in terms of setting breakpoints in lambdas. So what for is this talk? This talk is just because we need you. Yes, we need Sprox to join us and code, as is for us pretty crucial. And now is the time for demo. So we are here not just to look, let's say, not just to look at the, let's say, presentation, but also some piece of code and functionalities. Long bit too long, I think, and we'll just need to prepare you for some, let's say, thinking about the coding and starting to code, to show you that these things are, let's say, not so difficult as you could think after a few talks. But on other hand, let's say I would like to calm you down so you don't have to scare that about the coding in tools. Yes, this is a really very great opportunity to see things from other side, not only as a user but also someone who creates these tools. And at the very beginning, when you are using expression evaluator, it's worth to change maybe debugger timeout. This is pretty. Can be found here. So I know that this gray window is not seen from the back seats. Sorry for that, but unfortunately we do not support fonts size for this window. This is Eclipse. Eclipse was the first platform, so it has some limitations. But let's say many years ago when we started to create the Scala IDE, IntelliJ wasn't yet opened. So and we just use existing let's say platform. So when you need, this is simple to set this timeouts. When you just put here the debug, you should get the exactly. So this is this view, and here you can set the debugger timeout. Why am I talking about that? Because during debugging, we have actually two machines. Yes, we have a debugging machines and debugging machine. And the communication between these two is done through JDI. I will talk about that later. Yeah. About that later? I'd like Stevie Wonder, okay. Not to eat it. And sometimes you can experience that request is not finished, let's say is timed out because of timeout, and you can just increase this timeout using these settings. So let's say cancel. And what for it is, yes, let's say that we have such simple class. This class has some value. This class also has a method. And we are executing this stuff in some context. So this context is that's what we execute. Yes, and let's say that really very basic functionality is just to evaluate things variables we found in our context. So for example, I'm writing underscore acme, and I will explain why there is an underscore in some moment. So this is pretty simple, and we can evaluate it. But this is nothing extraordinary in comparison to that what we have in variables view. Yes, this is also available here, but we can evaluate as well that what is Scala. Okay. Does not fit. Okay.
But it's nice. Okay.
Move it. So so mostly we are using these devs is because when we are writing code in Scala, Scala is pretty cool language because somehow enforce us to create immutable objects and sometimes to compute the state of see some things where we create a kind of view on it with such kind of method, and this method are not available in variables, but here they are. Yes, so I can write here a help me and evaluate it, and I see that okay, under that is hidden help me object with some settings, and also I get a tree and content of this object. Its values and variables as well. But this is pretty simple usage. Let's see what we can do more. So let me disable this breakpoint, and I have another one. Okay, number 3, let's say. Yeah, we can also evaluate things like function, which are calling a function. So when I run this guy again and stop the breakpoint,
Maybe you need to stop debugging first.
Excuse me. Enable, disable. Ah, okay, you're right. Sorry. Disable this guy. Let me stop the. Okay, would be better. Disable and okay, this one is enabled. So let's run it. So I can also evaluate the function. Not this one. So now I just put this line into expression of evaluator. Not sure if we, but so if we interpret also comments, that's the reason why I remove it. But you see, I have a result, but I can do even more. I can put here in this place some lambda. For example, I will get this. So the issue is that I have an integer, so let's say that I get this integer, turn it into string, yes, and I add some text to the lucky number, maybe number. No, excuse me. Yeah, so again, I get the result which is done or received from expression evaluator, but else I can do something else. So I can be okay. So I can also evaluate, let's say, this man. So now I have some function which gets a list of function and lambda on it. I see that I do not have right now created object, so when I put an outer, I write here an outer, yes, to see if this object exists or not. It's just a null, so let me create so I can even do such things, which is pretty fine. I can stop in breakpoint inside my function. So now I disabled this breakpoint. I have enabled breakpoint here in bus function. So I'll stop it. Maybe I could go further, but I stop here and let me evaluate this line. So you see an error, yes? So this is an opportunity for you to fix it. There is a workaround on it. The problem is that this collection, when we go into inars, you will see that every, let's say, type argument and turn into something which is called JDI proxy. It doesn't matter what it is, but and you see here it. I know that you guys, you don't see it because this is too small font, but here is a message which says me that expected function or required function is something which turns JDI proxy into Boolean, and was found function which turns string into Boolean. So the simple trick is just to cast it to JDI proxy Boolean. Yeah, so we get a result, but there is also some pitfalls. This is because our code is not perfect. I mean, there is many corner cases currently which are not covered, but many other are covered. We have 188 tests for expression evaluator. So you can imagine how many corner cases already have been covered. But still there is some set, maybe even bigger, which are currently not covered. And also sometimes we struggle and face the problems with toolbox, and I will show you one example on it. So the first one is about the names. Yeah. Here I put the breakpoint in this place, and I have an Acme variable here, a value in actually, and yes, and when I evaluate it, so last time there was underscore Acme, and it was successfully evaluated. Now it is an Acme, and we have a problem, yes? The problem comes from the conflict between the name of this value and the name of package where this value is. So now we don't know exactly how to solve it, but I hope maybe we'll find some workaround on it. Another example, which is this time our problem is about instances of classes which are defined inside object. So when I try to evaluate this man here, not this guy. Yeah, so again, we will get an error, unfortunately, and this error comes from the fact that I will show you maybe. Okay, I know that you don't see it, so I prepared some really very special notepad. So the problem comes from the fact that the inner class is accessed with this dollar instead of dot. Yes, if we change it, it will be working, and this is easy proof to for example, in this wonderful tool like REPL. Yes, I have an example here. So when we turn it into dot, fortunately, it is possible to compile, and then we can do it. But this is bug. This is something where we will probably need your help as well if you want to have it fixed in quite fast time, short time. Okay. And I think that after this day, you will dream about woods, because everywhere are trees. Yes, and in this case also there are trees. These three links you can see here, this is my way how I, let's say, get acquaintance with trees. So the first one was nice and introducing presentation of Chris Bircher. And then, but I think that the best one to start is just to read and try the tutorial about reflection, or for reflection in Scala lang, just a Scala lang doc. Yes, this was for me a starting point, and I have to say this is pretty fine. The last one was already mentioned by Matthias. This is a little bit stale because it comes from 2009, and unfortunately, because it is master thesis, does not have a second or third edition. So, but many concepts described there are still living and worth to look at. Other thing which is required in writing the stuff in tools like Scala IDE, but I also suspect that in other IDEs as well, is a Scala debug interface. And the documentation, it is something really small and short, maybe with gaps, but that's what you would find in this link. It is pretty, let's say, good enough to start, at least, let's say, from my perspective and my experience. And how looks inars in this, looking, let's say, based on these two things, yes. When we write Acme in this window, in reality, the expression evaluator sees as a tree, yes. So this one is a pretty simple tree. Fortunately, this tree is not typed, so we can proceed with this thing. And in the case when I would just call here a type check, I will get an error that this symbol is not for this name. I mean, let's say for this expression, is not able to find the type. Yes, and then with transformation of tree, we as a or maybe I, as an expression evaluator, change this Acme into block of code, and I put this one, let's say, is our synthetic variable. Yeah, so we turn it into synthetic variable, and we also get a type of this variable, and from where we are taking it. So there are two sources. One is frame on stack frame, and second is from presentation compiler. Unfortunately, this talk has to be more like lightning one, because we are out of time. So, and do not, let's say, the way how presentation compiler is involved in this process will be, let's say, a part of rather whole talks, not here. But this is possible to find this type, and we just assign here some placeholder. Actually, this is a nothing. I mean, this is a triple question mark. What for? We just when we create the code, yes, we just want to be assured that this code is possible to compile. So when we create this thing, and we see here we have this triple question mark, we see that for toolbox it is possible to solve all types of this stuff. And when we have it, yeah, finally the final step is just to replace the placeholder with a real value, which is taken from frame. JDI defines, I could call it mirrors, generally speaking, and I think these are called mirrors. So counterparts of variables which are on the debugging machine. So we have a mirrors of real values, and we need to get these values. So not sure if this piece is working, but generally I think that nicely reflects the idea which is hidden under the bonnet. So this code then is executed, and then we will see result of this ACME, result of this statement in the expression evaluator. So that was about expression evaluator. Now about us in the debugger. So I will present you 3 features already done and running. Right now, Async Debugger is a tool which is working in some, let's say, in some context with futures and akka and Scala actors. Futures are available. I mean, futures concerns only one part of this tool. Yeah, I mean, documentation can be found here. So if someone of you would like to use it, you can refer to that and see how it is, how to let's say use in some detail some particular use cases. I know that these 3 things is too little, but we have an open ticket to make available Async Debugger also for let's say homegrown actor systems. Yes, and this will be, I think, shown how can be done a little bit later. So let's present it. Okay, the first one will be about history. So we can trace the call of messages. In the past, we can go in the past from where given message came to us. And as I said, in case of history, we can also use it to trace, for example, how futures were called. So we have a future 1, future which let's say invoke the future, or another way, put into the queue, yeah, future 2, and we can go back and see from where this future 2 has been called. But this example is about the Scala actors, And okay, now we see here, I know that this is really very tiny font, but here in the black font is a place from where in reality this message came. So we are here in the receive, and we see that hello world got a message done. So now we would like to go back from where it came and see, okay, it came from this time from greeter, yeah, and from where this guy came. You see that this guy from another man, and we can go back up to the, let's say, the beginning, the origin of this message. So we see that we started from method pre-start. Yes. And another feature, not this man. Another is, we call it as a step until a message received. So let me deactivate or disable this breakpoint and enable another one. So, okay, I see, okay, I'm in here, I got the message greet me, and I can go further. Say, and see where I land if I send this message. So now I can run. Okay, it is not true. That what is interesting for us is here. This guy stopped because there was an established breakpoint, and in between, in this line, we send this message. Yes, so this is the stack trace. This is that stack trace. We are interested in this guy. So I see we land in greeter. We landed in greeter. And when we go further, okay, so this is greet me message. Print line, we can continue. Meantime, something has been written on the console. And this one comes from another call, yes. And the last one feature is a counterpart of stopping when the exception is thrown. So we have something like break when message arrives in dead letter. So stop when dead letter was discovered or sent. So let me. Okay, so we see that we got a dead letter, and we also have information about message and what actor sent it, and that information sometimes is pretty helpful in case when we let's say suspect that system is eating some or shedding some messages. I'm not sure, but right now, I don't know. I think that maybe we will skip some pitfalls which are related to that. Let's go to innards, yeah. And as I said, it is really very helpful to know a little bit about the JDI. From our perspective, is just to see that there are something like breakpoints or step requests and events, and we should also know a little bit about the stack traces and frames as a part of JDI, or even more about object reference. So how it is working. I choose this one because, as I said, this maybe it is pretty similar to that what was done by guys from IntelliJ. Not sure. We'll check tomorrow. So first of all, we define some point cuts. The name is this was my intention, yes, because this is similar to that what we have in aspect programming. So we want to stop, or we want to set a breakpoints in these methods. As you can see, right now this is hard coded, but we have an open ticket to expose it as a configuration. And if this will be exposed as a configuration, there will be a possibility to define this kind of point cuts also for homegrown actor system, for example, in case of Twitter, probably. Yeah, so when we have this defined, and remember that we stopped in place where the message has been received by our actor, yes? So in such case, we can do two things, yes? When we stop and we push the back button, we actually set step request, and step request is something which is doing steps. So we see that the debugger is trying to execute every line, yes, and in executing every line going inside the code, causes emitting the step event, yeah. And now when we get the step event, we can do two things, yes, or we do not found any. Here, maybe this is inverted the order of execution. So this one maybe is more important. Or we found in our code the method which sends a message. In this case, we try to remember, among other things. Yes, this one is the most important. So we are trying to get the message, store it, and then just to find out that the place where we receive is exactly handling the same message. So we store this information and we set the breakpoint in receiving messages. Or if we do not found it, we just terminate our breakpoint and we halt. So pressing it will behave in this case like step over. Yes, this is the same functionality. What is going further? So here we see that we continue. So we allow the machine to run further. Yeah, and when we get the breakpoint, when we hit this breakpoint, we check if the message which came to us is that what has been stored when we send it, and if yes, we change let's say our breakpoint into the steps. So we send send the request, but just we execute now the test. So we just check every line of code to find out the place where the message is received. Why it is done in this way? Because when you look at the received message, this is just a partial function, and we are not interested in stopping in partial function definition. We are interested in stopping into our definition, our overloaded partial function in our actor. So this is the reason why we are doing it. And finally, when we found it, yeah, we just halt in this place, in this moment. Yeah, so this is how it is working, and then you could see that when I was pushing the step until the message received, I was stopped in the received message. This is caused by this piece of code. And what for it is all? It is like, I know that this movie was done some time ago, but I was inspired by Bilbo Baggins, and he's unwilling to join Gandalf and Dwarf Company. But let's say I forced myself to do this, and I have to say that it was really very wonderful time work on the tooling, and not only not only on the business side, but see how things looks like, let's say, from the perspective people who are working on this piece of code. So that's it. Any question to that? So tomorrow is a hackathon, and we will implement also again something on trees, organize imports. So if you really want to know a little bit or feel a little bit trees, come there.
Okay, just let me check my list. Yeah, basically I don't have a question, but a few things to add. So first of all, I think that after Wieslaw added this support for different launchers, expression evaluator should be pretty usable. But obviously there are some missing features, similarly like in case of IntelliJ, I think is ideal. And also there are some problems which can be, as Wieslaw said, caused by Scala's toolbox. So we don't have a way to fix this without changes in toolbox itself. Why this toolbox is important? Because how do we execute this expression which one types? Basically, we get a tree from the expression, then we traverse this tree to get, okay, initially you have some tree of method calls on some objects, and we traverse this tree to turn this into the tree of JDI calls on some mirrors of objects which are which really exist on the debugged machine. So when we transform this tree to tree of JDI calls, we execute this in toolbox, and sometimes toolbox causes problems. And okay, just some additional information. Obviously, when we call some methods on primitives, we don't send this call information to debugged machine, but we can simply compute this on the local machine. The another thing is that, Wieslaw didn't mention this, but it's not needed to always copy and paste expression to this window with evaluator, but we already have, or they have, the button, so you can click on the button. There also was the shortcut to send some code from editor to expression evaluator and execute it, but at some point it turned out that while I'm working on Windows mostly, I added the shortcut which conflicted with some other shortcut on Linux, and then Simon changed it to other shortcut which was okay on Linux, but wasn't on Windows. So finally, I think that we ended up without this shortcut at all. So just a few words from me.
Yeah, so I think Michał just wanted to say that this piece of code is get by tree transformation. It is not the pasted the text, yeah. So this is done with tree transformation.
Sorry, and the last thing, because I remember just. Thank you. And unless something changed, I'm afraid that there is no real code completion in expression evaluator. So unfortunately, there's nothing like that in Eclipse, but it's available in IntelliJ. There's an option in Scala IDE to turn what I called, I think, trivial experimental code completion, but it wasn't based on Scala presentation compiler, but it was the result of my first experiments with Scala reflection, so it's not ideal, and I'm not sure whether it still works.
Okay, thanks
thanks for this additional explanation. But yeah, anyway, the expression evaluator is available, so you can just try to use it. Maybe you won't run into problems, but you will get value from it, as actually it helps in debugging simple things, maybe not some simple things, but daily code. Okay, are there any more questions maybe to this subject, to this topic? No, so let's take a short break.
There is one.
There's one.
Hi, Wieslaw. One question. Okay, so maybe we'll repeat. Does it work with debugger with remote actor system?
This is pretty simple. You have to just choose another launcher. So there is a launcher for the remote debugging, and when you launch it, you will have an availability to join to that. And there is no, let's say, a difference between working on the remote machine in comparison to that what we have on the local one.
But if using multiple JVMs for debugging, it might be hard. It's like multiple remote actor systems.
Okay.
Okay, so thanks Wieslaw. Let's thank Wieslaw for this presentation.